All right, today we're looking at some mass-to-mass stoichiometry. We're just going to build off what we did it in our previous essential question, but now we're dealing with mass instead of moles. So we're going to treat this just like any other dimensional analysis problem. We know we're going to use dimensional analysis when solving stoichiometry problems. So we're going to begin with our dimensional analysis setup and then begin to break down the problem. So that's my first step, draw my dimensional analysis setup. Second step is to figure out what this question is asking me for. What is my ending unit going to be? And it's asking me how many grams of potassium chloride. So thankfully enough, we've been given this balanced chemical equation to start with. And some nomenclature is really important in this problem because I have KClO3 here and I have KCl. So the difference between potassium chloride and potassium chlorate is extremely important. We know that polyatomic ions typically end in ate or ite, so that's the KClO3. So potassium chloride ending in IDE is just KCl. So it is asking me for grams of KCl, or grams of potassium chloride. And then my next step is to figure out my given, or my starting point, which is my given, excuse me. And so how many grams of potassium chloride are produced if 25 grams of potassium chlorate decomposes? So 25 grams of KClO3, that is my starting point. All right, so at this point, I have everything I need to figure out the conversion factors in my problem. And I'm going to start with my mole ratio. Every stoichiometry problem is going to have a mole ratio. And I'm just going to make a mole ratio between this substance, what this question is asking me for, in this case, potassium chloride, and this substance related to my given. So I can go back to my balanced chemical equation. So I have 2 moles of potassium chlorate to 2 moles of potassium chloride. So 2 moles KClO3, 2 moles KCl. Remember, it doesn't matter which one goes on top, which one goes on the bottom. Remember, our balanced chemical equation is like a recipe. So if I'm going to make 2 moles of KCl, or potassium chloride, I need 2 moles of potassium chlorate. So now I have my mole ratio. Now I'm going to start looking for keywords, and this goes back to the mole concept. So right now I want you to take a look at your reference sheet, your 4 conversion factors from the mole concept, and we're going to look for those keywords. And keywords are things like particles, atoms, molecules, formula units, things associated with mass, so mass or grams, and things associated with volume, so volume, liters, milliliters, centimeters cubed, things like that. And what I'm trying to figure out is what conversion factors am I going to need to kind of work through this problem. So here I see grams, and that's a keyword that I need the second conversion factor, which is molar mass. So I need a molar mass conversion factor for this substance. So 1 mole of potassium chlorate has a mass of however many grams of potassium chlorate. Oh, what happened there? All right, so again, you have to go through, and to calculate molar mass, you're going to add up the atomic mass of every atom. So 1 potassium, 1 chlorine, 3 oxygens. Again, you're going to add up the mass, the atomic mass of each of those atoms. So 1 potassium, 1 chlorine, 3 oxygen atoms. And that's 122 grams. So that's what that keyword grams tells me. And then I'm going to look over on the other side, and this is grams as well, this time for potassium chloride. So I'll do the same thing. 1 mole of KCl has a mass, in this case, of 74 grams of KCl. So if this was, say, a quantity of atoms, or in this case, maybe formula units of potassium chlorate, then I would use the first conversion factor. 1 mole is 6.02 times 10 to the 23rd particles. If this was liters, I would use the third conversion factor. 1 mole of a gas at standard temperature and pressure is 22.4 liters. So that would only be true if it was at standard temperature and pressure. But those are the type of keywords that I'm looking for. At this point, I have all the conversion factors that I need, And now I can just go to my dimensional analysis and solve. So I have grams of potassium chlorate here. I'm going to pick this conversion factor right here because as we see, it has grams of potassium chlorate. So 122 grams of KClO3 is equal to 1 mole of KClO3. Now I'm in moles of potassium chlorate. I've used that one. I'm not going to use it again. So now I'm going to use my mole ratio. In this case, I'm going to flip it over. So there's 2 moles of KClO3 to 2 moles of KCl. And then finally, I can plug in my last conversion factor. 1 mole of KCl is 74 grams of KCl. And now I can go to my calculator, again, multiply everything across the top, 25 times 2 times 74, enter that into my calculator, then divide by each thing on the bottom, divided by 122, divided by 2. Again, mathematically, there's a lot of different ways for you to do that in terms of order of operations and stuff like that. But you want to make sure that your calculator is doing what you think it is doing. So that comes out to 152 grams of potassium chloride.